Hello, everyone. Welcome to the webinar. This is part 2 of the eSpire Nano webinar series. Today, we're going to be doing an installation overview. We're going to dive into a little more technical details compared to the previous time. My name is Ovtan Ilgiorkadze. You can call me Chio. I'm a senior product engineer on the CNI side here at Fortis Power. And let's start with a quick recap from the last time. Previously, we were introducing eSpire Nano and providing a brief overview. I think it's worthwhile to summarize that this time around too, so it will be a refresher for people that were attending the previous webinar, and it will be maybe a group of new information for the people that have not attended the previous webinar. So as said before, eSpire Nano is comprised of the battery unit and the inverter. That's what creates a well-integrated eSpire Nano system. And we were also saying the previous time that the Nano energy storage system is multifunctional. It is scalable. It is modular. It is ready for solar and generator. It has advanced EMS logic to it, and it is an energy storage solution for three-phase commercial and industrial applications, by which we mean that this system is directly compatible with 480 volt three-phase system and 208 volt three-phase system. There are, as I said during the previous webinar, there are other voltage signals with which the unit can work with, but since we're in North America, at least most of us, we are going to be talking about the more relevant ones, which are 480 and 208. About multifunctional, let me remind everyone that this system can support self-consumption, backup, export priority, off-grid, peak shaving, time of use, modes of operations, and even more complex strategies available with advanced EMS. That is for peak shaving and time of use. So you can do multiple peaks with the EMS rather than one peak threshold. And in terms of time of use, you're not limited to 6 charge and discharge intervals. As I mentioned before, this system is solar and generator ready. This is ready for both AC coupled and DC coupled PV. For DC coupled PV, it has a built-in APS transmitter, which works with the APS receivers, as we will see momentarily. And AC coupled PV directly connects to its smart port. So you can use that port for the generator, for a smart load, or for AC coupled PV. Either of these three. For the generator, it has also 2-wire start ports, and you can program the inverter to turn on the generator based on a certain state of charge of the battery. And obviously, we have all the relevant certifications, as you can see here. This is all due to the inverter and its capabilities, because if you really think about it, the purpose of the battery is to provide energy and store energy, but the inverter is actually what allows the system to interconnect with the rest of the world. So, quick recap on the inverter performance summary. We have 2 30 kilowatt units available, one for 208 and one for 480 volt systems. We also have 60 kilowatt inverter for 480 systems. The name of the inverter really suggests the rated output of the inverter on the AC side, except for the 30 kilowatt for 208, which has 26 kilowatt or kVA rated AC output. But in terms of features, they're all the same. Power ratings are different, and also 60 kilowatt inverter compared to 30 kilowatt units has one more MPPT. We're going to get into this deeper this time around, so bear with me for a moment while I'm finishing with this summary. There are certain rules that need to be followed when installing the system. These are some general rules. Nano inverters may be wall-mounted or wall-mounted directly onto the battery cabinet. Because if you think about it, the battery cabinet wall is just another wall. It's just it has the holes for the screws to support the bracket already in place. You can have up to 6 inverters of identical type working in parallel. There may be up to 3 nano batteries of identical type connected per inverter, but that doesn't mean that if you have multiple inverters, that they need to have identical energy storage size. 2 nano inverters may not share one battery or battery group. but multiple batteries can share one inverter. Up to 3 batteries can connect to or operate from the energy provided by one inverter. Nano inverters working in parallel, they all should connect to the same AC panels with the same ports. So you cannot have the situation where you have multiple backup panels and one inverter is responsible for one and the other is responsible for another, or you have multiple inverters. Maybe there be batteries connected to each inverter or not. You cannot have some of the inverters having interconnection with a generator output and some of them not. If you have uneven distribution of batteries between the inverters, it is strongly recommended that PV is distributed proportionally to energy storage distribution, so it's easier for the inverters to keep the batteries balanced at the same SOC level or around the same SOC level. Let's quickly visualize these concepts. So here, for example, you have 30 kilowatt 480 volt inverter and 30 kilowatt 480 volt inverter. They're identical type and they can work together, but you cannot mix 30 kilowatt 481 and 60 kilowatt 481. Same goes for the same AC output inverters. So on this last one here, you see that there are two 30K inverters, but one is for 208, the other is for 480. They cannot be mixed. As I was saying before, it is okay for each inverter to have its own battery. So there is no connection between the inverters and the batteries on the DC side. One battery connects to one inverter in this case, but one inverter does not have communication to the other battery. It only works with its own battery, but they are interconnected on the AC side. If you want to have multiple batteries per inverter, this is the way to do it, as you see right here. And these are the things that you cannot do. One inverter sharing multiple batteries directly instead of battery one connecting to battery two, for example, as shown here. You cannot have two batteries interconnected to one another and then interconnected one to each inverter, for example. And you cannot have two inverters working with one battery. It is okay to have some inverters working without battery, and previously I was outlining that the benefit of this is that within the same monitoring system, you have the inverter that serves as a string inverter, so you don't have two places to go to determine your total PV production, for example, right? And before we dive deeper, this is another important thing. We also have previously what you were seeing on all these little diagrams were the outdoor batteries. We also have indoor racks. All batteries and all inverters are compatible with one another. So 40 kilowatt hour battery can work with 30 kilowatt inverter or 60 kilowatt inverter, although it must always be ensured and guaranteed that the inverter cannot overcharge the battery. There are multiple ways to do it. We're going to go further into the presentation. I'm not going to spend too much time on it, but it is unacceptable for the inverter to overcharge or over discharge the battery. So there must be some measures taken such that that cannot possibly happen. And also, when the system is in operation, there must be closed loop communication between the batteries and the inverters. So if the batteries are interconnected, they must be in communication. If batteries and inverters are interconnected to one another, they must have closed loop communication with one another. And if inverters are working in parallel, they must have communication with one another. So just a quick note about scalability, which I mentioned before. With this compatibility thing in mind, the smallest system that you can have is 40 kilowatt hour or 26 kVA energy storage system. That is the smallest configuration. And the biggest configuration will be 360 kVA inverter bank. That will be 6 60K inverters and 1.08 megawatt hours. That will be 18 60 kilowatt hour batteries, right? So we're done with the summary. Let's look at the ports, technicalities, the environment for installation, and so forth. Again, before we do so, I must emphasize one thing. This is a new product. I cannot guarantee that this information that I'm providing will remain valid for eternity, because this is a new product. There are some ports that we don't use. There are some ports that we prefer to use rather than others. There are things that we don't allow at this moment, but um, that can change, right? That can change at some point in the future. So, for example, if we don't allow something, but we did extensive testing and determined that it is safe to do something for the equipment and for people and for the users, then we might do it. One example that comes to mind is currently we're not allowing the ATS and the generator being upstream of the inverter and connecting the ATS output connecting to the grid ports. Currently, that is the rule, but at some point that may change. Again, I don't know whether or not it will. I don't know how soon it will, but if it will only change if we have tests performed and confirmed to ourselves that yes, this can be done, such that the user experience will not be bad or it will not be unsafe and so forth. So the information that I'm giving you right now is valid up to this date, up to this moment, at the moment of recording this and conducting this webinar. But again, certain things here are subject to change. So keep an eye out for our newsletters. And also, once we have released the product manual to the broad public, once there is a change, it will be reflected in the manual, and the new manual version will be available. And the way I was explained is there will be no physical manual available with the system, but there will be digital one, which makes it easier for us to keep it up to date, because digital one, you can change it, and next time someone scans a QR code and goes to the link, they access the latest one. But if you have one paper manual that you have used previously, that paper manual is frozen in time. So we will not obviously reflect the changes that we make. So with that out of the way, as I said, let's dive deeper. So previously, I did show you the inverter, but I did not show its geometric dimensions. Here they are, 26.6 inches from side to side if you're standing in front of it. It is very important to note here, this includes the dongle on the side and the switch, because they kind of stick out from the body of the inverter, but they are included in this width. Height-wise, 44.5 inches, and depth, 13.7. The inverters are around 197 pounds, which is not too surprising considering how much power they pack and how many features. But again, this is a heavy unit. We strongly recommend that no less than 2 people work on installation and maneuver the equipment in the field. Now, we had performance summary shown before, but now let's get into it deeper. So, as I said before, these inverters are equipped with MPPTs for DC coupled PV. 30 kilowatt inverters have 3 MPPTs, and 60 kilowatt inverters have 4 MPPTs. Maximum estimated PV input power, so the estimated PV array size that you can connect to these inverters, is estimated to be 100 kilowatts for 60 kilowatt inverter and 60 kilowatt for either 30 kilowatt inverters, may that be 208 or 480. MPPT voltage range for each MPPT, no matter which inverter model we're talking about, is 150 to 850 volts. But again, this is the range in which the inverter can do maximum power point tracking. This is not the maximum open circuit voltage range. Maximum open circuit voltage can go up to 1000 volts. And beyond these MPPT voltage ranges, the inverter will still try to turn the PV power into useful power. It's just it will not be maximum power point if it's outside of the MPPT range. For those who are going to be sizing the PV array and the strings for these inverters, it will be very important to know that maximum short circuit current per MPPT is 65 amps. Now, I must remind everyone that each MPPT can accept up to 2 strings. We're going to touch base on that later. So 65 amps is not per string. 65 amps is with 1 or 2 strings. So 2 strings combined should not exceed 65 amps. Voltage-wise, I'm not even mentioning that because your voltage really is not going to change. It's in series. So the strings connect to each other in parallel. So the voltages will be close, and the module quantity per string really determines the voltage. But when you have 2 strings connected in parallel, the circuit doubles, right? So pay attention to that when you are designing your system. Although I find it difficult to remember a model type of a PV that can exceed around 32.5 amps short circuit current. But again, there are extreme temperatures and there are new non-conventional modules, so to speak. So 65 amps is the limit. Maximum battery charge and discharge power for 30 kilowatt inverters is 33 kilowatts, not 30 kilowatts. And for 60 kilowatt inverter is 60 kilowatts. A rated AC output when the grid is available is 30 kilowatts for 480 30 kilowatt unit. It's 30 kilowatts for 208 unit and 60 kilowatts for 60 kilowatt 480 volt unit. But as I was saying before, the backup power that the 30 kilowatt 208 unit has available is slightly less than its AC rating. So it's 26 kVA of backup power. Currents you can see here for yourself. Maximum generator AC or AC PV current input is 36 amps for 30 kilowatt 480, 72.2 for 60 kilowatt 480, and 72.2 for 30 kilowatt 208. One will notice that this is actually the nameplate ratings, AC ratings for these units. So 72.2 amps for 30 kilowatt 480, that translates to 30 kilowatts, right? And 72.2 translates to 60 kilowatts at 480, and 72.2 at 30 kilowatts translates to 26 kilowatts. Now, we are entertaining an idea of allowing 120% compared to AC rating when it comes to the generator. So for example, if you have 30 kilowatt 480 volt unit and you want to connect a generator to it, rather than capping the generator input to 30 kilowatts or generator output to 30 kilowatts, we might in the future allow to have 120% of that 30 kilowatt. But again, this is just an internal conversation. I don't know what the final conclusion will be and whether or not we implement the change. So for now, generator or AC coupled PV must be equal to or less than the total backup kVA output of all the inverters working in parallel. That is continuous kVA, because as you see right here, for brief periods of times, the inverters can output more current than their continuous rating suggests. And you can see the numbers for right here, which is a good perk, really, but I would not necessarily rely on it too much, because again, these are for limited periods of time. So 43.3 amps compared to 36.1 for 30 kilowatt 480 unit. That 43.3 is only for 5 minutes. It's not continuous. Very important to understand. That's why I gave the time ranges there for every single one of these values. So this is kind of slightly more in-depth overview of the inverter summary. You can find the complete datasheet on our website, which you're more than welcome to visit and go to the Nano page. Whatever new we have and whatever documents we release for the general public will end up there. Now, let's remember what is included with the inverter package. The inverter itself, wall mount bracket, fastening screws, expansion bolts. Expansion bolts will be used if you are not mounting the system onto the battery cabinet. Communication dongle, which is exactly what it is. It establishes the communication to the cloud, Wi-Fi, everything else. Communication cable, 9.5 feet, but I am trying to change that and provide a longer cable. 9.5 feet is really enough, but not more than enough. So I want to have the cable in there, which will be useful for the people that don't necessarily mount the inverter onto the battery cabinet. So expect at some point to have a longer communication cable. Screw-in handles, which we will see in a moment what they do and what's the value in having them. Rogalski coil set, 600 amps, 3 coils. With these inverters, it seems like we'll not have CTs as such at any point. So even if I mention CT somewhere during the presentation, assume that I'm referring to Rogalski coil. It's just CT is something that we're all used to, and sometimes even maybe perhaps mistakenly we refer to Rogalski coils as CTs, but they work on a different, little differently than CTs. RJ45 connector and the meter. Now we will talk about the meter and the Rogalski coil later, but quick thing: meter will always be used, and although we have ports available for Rogalski coil set or CTs directly to be connected to the inverter, meter is a must, right? Now let's look at some of the tools that we might need in the field. Screwdrivers, wire stripper, crimping tool, channel lock, multimeter, hex screw tips, torque wrench, all the things that we are really used to seeing in the field. But for those that have not worked a lot on three-phase systems, the last one here, phase rotation detector, could be a new item that they have not necessarily used in residential, because in residential, you are working with one phase, which is split into two. So that 240 is one phase, and you have 122 neutral, that's your L1, and 122 neutral, that's your L2. Here, phase rotation matters. L1 should go to L1, L2 should go to L2, L3 should go to L3. So while you're connecting those AC cables to the inverter, you must check phase rotation to make sure that the rotation is correct and the inverter is not going to go crazy and throw errors when you turn on the AC input to the unit, right? So phase rotation detector is a must when working on these three-phase units. Next, one must be very careful to while selecting the while selecting the environment in which the inverter will be installed, and one of the first things to pay attention to is the ambient temperature. The minimum ambient temperature for the inverter is minus 13 degrees Fahrenheit, and the maximum ambient temperature is 140 degrees Fahrenheit. Relative humidity is up to 100%, but non-condensing. You'll notice I'm not mentioning batteries here. They have even wider slightly temperature range due to the HVAC that we have in place. So that is something that we're not going to mention during this webinar, and we'll have that written on the spec sheet. So the temperature range for the cells is the temperature range for the cells, but that is very different from the cabinet ambient temperature range, because the HVAC on the system does warm up or cool down the batteries as needed, but the cell temperature range will be more relevant to the indoor units. So for that, the temperature range will be slightly narrower than for the outdoor units. But since this is an indoor installation, I'll find it difficult to imagine the indoor installation in which the temperature falls below 4 degrees Fahrenheit. And even if it does, we're talking cell temperatures, not ambient temperatures. But for the inverter, because it's sitting outside and it does not have a dedicated enclosure and it's not heated or cooled via HVAC, it is very important to keep these temperatures in mind. Another thing that has to do with temperature is that we are not allowing installations in which the inverter is self-facing, right? Because we're in the northern hemisphere, and on the south-facing wall, especially in the summer, and maybe fall too, but on the south wall, the inverter will be exposed to direct sunlight for a prolonged period of time, which can fail the HMI screen very quickly, can overheat the internal components, And remember, this is an air-cooled unit. This is not liquid-cooled. So uh, perhaps it does not have as much cooling capacity as your car would with a radiator, right? So it is very important that if it is installed on the south-facing wall, there is an adequate shading so the unit is not exposed to the direct sunlight. I don't know. I don't know for where this webinar finds each and one of our attendees today, but just a side note, maybe it's useful to mention that in the southern hemisphere, you try to avoid the north-facing wall. And again, that is without the shading. If you have adequate shading, you should be fine. Then, nano inverter must not be installed in areas or rooms where the air cannot circulate freely because, as I said, this is an air-cooled unit. Obviously, it cannot be installed in a living area or dwelling area. You're not going to put this in your living room, I'm sure. It cannot be near flammable substances. There must be certain distance from any flammable substance, and that distance is 10 feet or 3 meters. And the elevation limit is 8,208 feet or 2,500 meters. Now, again, this could be a subject to change. Maybe we're gonna come up with a D-rating table. So by every 100 meters, you rate the system by so much, and that kind of will help. But again, that elevation limitation is due to the fact that this is an air-cooled unit. Higher the elevation, lower the air density, so lower the cooling efficiency. Right now, as I said, this is the limit, what I mentioned a moment ago, the value. But in the future, we could come up with a D-rating plan and deploy that. But for now, adhere to this limit, please. Next, clearances around the inverters. So it should have 20 inches of clearance in either direction around it, right? Top, bottom, left, right, unless it has another inverter on its side. So distance between the inverters is even greater than 20 inches. That is actually 31 and a half. That comes down to 800 millimeters, which is 0.8 meters, almost 0.8 yards. So the reason behind this bigger distance between them than 20 inches is, again, because they are air-cooled. So they create kind of layer of warmer air around them. And we don't want that overlapping, and we want to avoid that as much as possible. So these are the numbers to follow. At some point, I will also create a diagram which shows the clearances between the batteries when they have inverters attached to them. So this will be applicable for when you have batteries mounted onto the inverter cabinets. I'm sorry, inverters mounted onto the battery cabinets, and when you have inverters mounted on walls, not on the cabinet itself. And this rule is true even when the battery cabinet supports the inverter, but perhaps it will be easier to show the diagram in which battery distances are shown. And those distances, by default, establish that these clearances will be kept between the inverters. So I didn't have time to create it for this particular webinar, but at some point I'm planning to do it. Next, talking about the wall installations and wall brackets, we mentioned that multiple times. On the right side, you see the dimensions of the wall mount bracket. And as I said before, this is included with every single nano inverter. Even if you're installing the inverter onto the battery cabinet, this bracket is the one to be attached to the battery cabinet wall, and then the inverter is hung on it. The bracket must be flush against the surface on which it is mounted, so no gaps anywhere. It is very important that the arrow that has that the bracket has the arrow cutout, that should be pointing up, because you kind of hang this inverter on top of this bracket. So if the arrow is pointing down, there's nothing to hang the inverter onto. The wall which you use to mount the inverter must be non-flammable. That is addressed by default when we're talking about the battery cabinet because it's made of steel, so it's non-flammable. But installing this on a wooden wall or something like that would not be acceptable. Also, another thing I want to mention is there should be no incline, right? So if you take your level, right, it should be perfectly vertical, the surface on which you're attaching this bracket. There are 4 fasteners. There are 4 screws that goes on into each corner of these brackets. So all 4 of them must be used. It's not like you can put the top 2 and skip the bottom 2. That will not have the system structurally balanced. So all 4 of them must be used. And it is allowed to have one wall supporting 2 inverters on opposite sides. But in that case, width of the wall, i.e. distance between the brackets, must be at least 12 inches. And the wall, whichever one you use, must be able to bear 4 times the total inverter weight of all inverters that the wall is to support. Moving on. So this we kind of went through. I also mentioned the handles that that they are included with the inverter. There are 2 of them. They are screw-in handles. So once you open the box, the handles are included, but they're not attached to the inverter. They are screw-in handles, so you screw them in. You don't have to use a tool to have it necessarily tight. Firmly, snugly, hand tight is good enough. You put in the handle on each side of the inverter, and that allows you to lift the inverter more easily because the inverter itself doesn't have any other handles whatsoever. Now, when you install the inverter, you are allowed to remove those handles. But honestly, if you prefer to keep them on by whatever reason, that's also fine. As I said before, you should not be alone when you're handling this inverter. It's very heavy, at least 2 people. And please do it safely, handle it with care. Don't hurt yourself, don't damage the equipment. So handle it gently, and you are more than welcome to use special equipment, hydraulic, mechanical, some other type, to lift the inverter and put it in place. I personally, when me and my colleagues were installing this inverter onto the battery cabinet in the lab, I used engine hoist. But I also understand that engine hoist is not always an option. So whatever makes it easier for you, as long as you don't harm yourself or someone else and don't damage the equipment, you can, I guess, get creative with it. Now, next, to mount the inverter, once the bracket is secured, you lift the inverter, and the bracket has a lip over which the inverter goes, and you hang the inverter on it, and then there are 2 screws that you install in the bottom of the bracket to stabilize the installation. Otherwise, you can like touch or grab the inverter and pull it towards yourself, and it will rotate around that lip which supports it. So to prevent that, please use those 2 screws that are included. Next, now it's getting a little more interesting, at least for me. So the inverter has multiple conduit entrances. So far, there are no conduit entrances on the backside of the inverter. You have some on the top, you have some on the bottom. Or sorry, you have some on the sides, and you have some on the bottom, and they are labeled. If for whatever reason you find it easier to not follow the labels and connect the conduits against the label designation, really, you're welcome and free to do it. That's totally fine. As long as the cables get to the right place, not using the conduit entrances as labeled is totally fine. but there is no flexibility whatsoever on where the cables connect, right? And we see that some of the cable, so sorry. We do see that there are different ports for different things. Let's start uh, according to the numbers that I have put on the labels here. So number one would be DC cable PV ports. Strings connect here directly. Using ferrules is strongly recommended. As I said before, there are multiple MPPTs. Each MPPT has 4 ports, 2 positives and 2 negatives, right? And as you see here, this particular inverter has 16 ports. That means that there are 4 MPPTs, which means that this is a 60 kilowatt inverter. Number 2 is the battery ports. There are 4 of them, 2 positives and 2 negatives. Although the way we want these ports to be used is that even if you have multiple batteries, not connect one battery to one positive and negative pair and the other battery to another positive and negative pair. What we want to see is 2 cables coming from positive to one battery bus bar, 2 negatives coming to the other negative bus bar of the same battery. And then the battery itself has other batteries connected in parallel to it. So paralleling happens on the battery bus bar level, not the inverter port level. Number 3, smart ports. You see there are 3 of them for L1, L2, and L3. This is where you would connect your AC coupled PV or generator or smart load, whichever you want to connect there. Again, just to remind everyone, it is not allowed to have 2 things connected there at the same time. You need to decide what your end user must decide what this is to be used for, and that one thing will be getting connection to this the smart port. Then we have backup/load ports. These are normal backup ports. These are the ones that are on the receiving side of the pass-through. So grid passes power to the load via port number 4, or 3 ports labeled as number 4 here. And these are the ports that are energized if the grid outage occurs. Number 5 is where you connect the grid input. May that be whole site backup or partial site backup. The AC to the inverter is delivered through these 3 ports. That is number 5. And again, no generator on this side, no ATS with a generator on this side. Grid either directly from the meter or from a main panel board or some other sub panel must enter here. Only grid AC should be present at these ports. Although, to be honest, with pass-through, I would say most of the time you will not take the cables directly from the meter. But again, that could happen. You're more than welcome to do it. But remember, please, these ports are only for the grid. We also have DC ground bar, number 6. We also have neutral bar, number 7. And we have AC ground bar, number 8, right? Also, important things to note. If you connect PV1 plus and PV1 minus to one MPPT, use 1 pair each, because that is easier for you and that is safer for the system. So if you have PV1 plus and PV1 minus for the first, and PV2 plus and PV2 minus, the pluses and minuses must be grouped together. So one strings plus and one strings minus goes to 1 plus and 1 minus. Not like positive goes to 1 plus, but the negative goes to 2 minus. Please avoid doing that. It's not a good practice. Other than that, I mean, you see what you see on the screen. There are other notes about the PV that I wanted to share. So multiple times over this webinar, I have mentioned that each MPPT can accept up to 2 PV strings. These are DC coupled PV strings. It is extremely important it is a rule, it is a must, whatever you want to call it, that those strings are identical in all aspects imaginable. So module types in both strings must be identical. Module quantity in both strings must be identical. Both strings must have identical orientation in space. If there is, if there are bifacial PV panels used, all of them must have the identical gain. If there is shading, preferably there should be no shading, but if there is shading, the shading pattern must be identical between both strings. All of this matters so that the voltages of these strings are as close as possible, right? Compared to if you had two identical strings, but one is north facing and one is east facing. They would have different voltages. They would have different maximum power points at different times. So we don't want that, and you don't want that too. That can lead to faults, curtailing, clipping, all kinds of weird things. So please, if you connect two strings to each MPPT, make them identical in all aspects. That is not to say that strings that go to different MPPTs have to be identical. Quite contrary, they can be completely different from one another because MPPTs are autonomous. They're not directly interconnected in any way. Then I mentioned before that you can directly connect the PV strings here. That is true. And the reason why we're able to do that is because the transmitters are already built in to the system. Namely, we have APS PLC 1P transmitters here in the factory in the Nano inverters. The compatible receivers, there's a typo there, which is compatible with the following AP systems receivers, not the transmitters: RSD-D15 and RSD-S PLC. I know that some of you will have a need to use optimizers instead, such as Tygo, right? And in that case, this APS transmitter may not be of use at all. If you have external rapid shutdown system or optimizers or anything of that sort, the built-in rapid shutdown device must be disabled. Our manual will show how to do that, but to avoid crosstalk, having multiple of them working together is not allowed. You either use the built-in one or you use the external one, not both at the same time. So with that out of the way, you notice here that for the grid boards, for the neutral and ground bars, there are screws, but for DC coupled PV, for battery, for backup load output, for smart ports, there are no screws. That's because you don't need screwdrivers and screws to use these. These are like spring lock mechanisms that latch onto the cable, and you don't necessarily need a screwdriver to screw something in place. For DC coupled PV, no tool whatsoever is needed. You can use your fingers. For battery and backup and smart ports, you will need a screwdriver or some kind of a metal rod for that metal hole to open. I'm going to show you in a moment what are the precautions there as well. But more importantly, hex bit sizes required are given on the left for neutral, ground, and for grid. And you see here the conductor size range for each of these ports. This is very important. This will be part of the manual as well. And torque specifications for the cables that are actually going to be secured by the screws. Now, next, I told you that I would show you what precautions to follow when putting in these or when trying to operate these spring load mechanisms. So first and foremost, you want the screwdriver or the rod that you put into that hole to be long enough to reach it to the end, and also not have gap between the walls. I personally, unfortunately, did not use a proper screwdriver, and when I was closing the this orange thing in which you stick the screwdriver, that broke on the bottom. Happily, that was in the lab. I did not damage a customer's system, but please pay attention to that. Otherwise, damage cannot be ruled out. Also, when you're putting in the cable, um, half of an inch of sleeve or jacket of the cable or insulation must be removed, and you slide that in from the bottom, hold it in place, close the spring clamp, and give a gentle pull onto the cable to make sure that it's in place and it's not going to fall out. Obviously, all the way up is open position for the spring clamp, and all the way down is closed position. Now, it doesn't say this on the slide, and it will be difficult to show, but when you stick it, the screwdriver in, there will be one stage when it unlocks and this spring clamp can move freely, but that is not when the cable is allowed to move. You need to push it all the way back so it locks into unlock position, so to speak, and that's when you can easily slide out the cable. Okay, moving on. These are some of the communication ports that we have available. And here we have Ethernet ports, and we have normal ports where one wire goes in. Now, some of these are not used at all. Some of these can be used, but they're unavailable based on our use cases and how we say you may or may not install the system. So, for example, for the CTs, that will be ports 1 to 6, right? The top right table shows wire ports, and bottom right shows the RJ45 ports. So let's start with regular ports. First 6, they are for CT sets. That's for L1, 2 of them, for L2, another 2, and L3, again, 2 ports. But they are unused because we made the meter mandatory, right? Because we are trying to avoid the potentially negative consequences of using just the CT, inaccurate readings, bad contact, stuff like that. And also, meter gives us way more accuracy, and at a longer distance, meter is way better than the analog signal that is coming from the CTs. Then ports 7 to 14, they are unassigned. Number 15 and 16, those are for external switching signal, right? For some external contactor, you can provide the switching signal, but we're not doing that because that is the feature for Pro EMS, because we have not tested in standard configuration whether or not it can work reliably. Whereas with the EMS, we have been doing that for years just fine. EPO plus and EPO minus, number 19 and 20, that will be where you connect your external emergency power off button or switch. Gen DO1 plus and Gen DO1 minus. DO stands for digital output. So generator 2-wire start is Gen DO1 plus and Gen DO1 minus, and same for Gen DO2 plus and Gen DO2 minus. But DO1 plus and DO1 minus are not used, but DO2 plus and DO2 minus are used for generator 2-wire start. Then you have Gen DI plus and DI minus. This is the switching signal for the ATS that may be upstream of the inverter. But remember, we're not allowing the ATS to be upstream of the inverter. So these ports are not going to be used because that use case does not exist with our system. And we can repurpose this in the future, maybe. Then, now let's talk about the RJ45 ports. PA and PB, that is parallel A, parallel B. So parallel in is PA, parallel out is PB. That is for the inverters working in parallel. So, for example, if you have 3 inverters, right? PA from the first inverter goes to PB of the second inverter, and PA of the second inverter goes to PB of the third inverter. So that's kind of how you daisy chain daisy chain these inverters. DRM connection, we're not allowing that. It is unavailable. It is not programmed. It's not configured. We kind of have resorted in the future. Maybe we're going to use it for something. But right now, no, we're not doing it because, again, that is the Pro Package EMS capability. Because it's not enough for you to have the ports. You also need to have communication protocol with the utility. And communication protocol was developed for the EMS. Then RS-485, external gateway. We don't need to use this because external gateway functionality is absorbed by the communication dongle that we have in place. Meter, external gateway, that is available, obviously. That is for that meter that has the CTs connected to it. And we're going to see how in a moment. Port 6, or item 6 and 7, BMS1 and BMS2. They are pre-wired and they are connected to item number 10 and item number 9 from the factory. And that's where you connect the Nano BMS communication cable. And number 8 is Pro EMS. If you have Pro package, port number 8 is the one to be used. Now, I know that we have eSpire Nano BMS1, eSpire Nano BMS2, and we have eSpire Nano Ethernet. So BMS2 is unavailable because we decided to go with this architecture that you're not limited to 2 batteries per inverter. You're limited to 3. But the way the inverter operates is that batteries communicate to one another and primary battery communicates to the inverter, rather than having each battery communicate separately to the inverter. We found this to be more reliable. That's why BMS2 for now is not used. Maybe our further testing will show evidence that actually no, we want to have the other architecture, but again, that is the way it is going to be now. And eSpire Nano Ethernet. This is not for necessarily connecting Nano to the inverter. This is for you to be able to connect to Nano while it is in communication with the inverter. Let's say with your laptop, you're going to connect your Ethernet cable, type in the appropriate IP address, and you'll be able to communicate to the battery while it is already communicating to the inverter. So it's an Ethernet switch of sorts, that 9, 10, 11, that board on which it sits, especially on port number 11. It reminds me of an Ethernet switch very much. Next, external EPO switch. As I said before, we have the built-in EPO switch that actually triggers the RSD. If you install an external EPO switch, that EPO switch will not exclude the built-in switch from the picture. It's going to be either or, whichever one is pushed. That is the one that is going to trigger rapid shutdown and emergency power off sequence, right? Next, let's talk about the meter for a moment. So on the meter side, we have Ethernet cable that must go to the meter port that I showed you a moment ago, and only 2 cables are used, pin number 1 and pin number 2, and pin number 1 connects to TSX-A, that is transmitting A, and RS-485B, or pin number 2, should connect to transmitting B, right? You also need to have CTs connected to the meter, obviously. There are going to be 3 CTs that you are going to connect. So ports number 19 and 20 are for CT1, which is going to monitor L1. Ports number 17 and 18 are going to be for CT2, which monitors L2. And CT3 will be 15 and 16 for L3. And again, these L1, L2, and L3 must coincide with the reference cables that you have shown in the bottom. You see neutral, L3, L2, L1. So L1 must coincide with the CT1, L2 must coincide with CT2, and L3 must coincide to CT3. And also, these must coincide with the rotation that you have on the grid input of the inverter. That's why I said that grid input is very important, that it falls in the correct rotation category. And also, it is not connected here because this photo was taken before I did so. You have auxiliary neutral, NA, and auxiliary line, LA. The reason why it says either in parentheses is because you can use L1, L2, or L3. By itself, the reference cables L1, L2, and L3 and the neutral will not activate the system. It needs auxiliary line and auxiliary neutral. One of the ways you could do it, perhaps, would be to use, instead of running two reference cables, so to speak, very small cables, you can run one cable and at the end split it using Wago. And if you have, let's say, 3-pin Wago, one accepts the output from the reference, and translates into two, one going to line and one going to the line auxiliary. So, for example, instead of connecting cable from reference point directly to L1, that L1 would go to Wago, and that would split it to LA and L1. And again, each one could be used. L1, L2, L3 should be fine. Now, we spent a ton of time around the inverter, but as I said, inverter is more complex in its interconnection principle, whereas the battery, which you see right here, and I apologize for the amateurish photos that were taken in the lab. This kind of shows you that we are actually working on this thing. The battery itself comes pre-assembled. All you need to do is connect the DC cables from the inverter to the battery. Let me see if I can get my laser pointer here. Right here. So this is where the battery would connect to the inverter. As I said, 2 pluses and 2 minuses. This is the communication to the PCS. So from this port to the inverter. This is the ground. So you take this ground and connect to the ground on the inverter. And this is the AC supply for the battery cabinet. This you can connect to any phase, really. And what matters is that it should be on the backed up circuit if you are doing backup. So one of the easier ways I can think of doing it would be to use Polaris style connectors and having the cable exiting the backup ports and going to wherever it needs to go, L1, L2, and L3, right? And one of them having Polaris, and that Polaris having connection to this breaker. And then you would also have neutral, or you can take a phase. This has quite a broad range. And then this AC feeds the internal transformers to transform that AC into 24-volt DC that operates the internal circuits. So that's really all there is to the battery. We will perhaps create one more webinar session for actually commissioning the system. And that will be probably a shorter one, but it will show the steps and more complete picture of how this all interconnects together and how is the commissioning done. Meanwhile, one quick reminder, manual transfer switch is very much recommended. These are kind of conceptual diagrams of do's and don'ts that we kind of explored in the last or during the last webinar. And since we are at 1 hour mark, I'm ready for you to ask the questions. I'm going to try to answer them to the best of my ability. And yeah, next one will be probably more about commissioning than just technical overview of the ports and stuff like that. So let me stop sharing my screen. And sorry I missed the first webinar. For 3-phase, do you need 3 inverters? No, the whole idea behind these inverters is that you only need 1 inverter if obviously you find the power ratings of that inverter enough. If you will need more power, you can double or triple or quadruple the inverter quantity. But each inverter has L1, L2, and L3, making them ready for three-phase as such. How many PV inputs are available? Does it have more than one entry port by MPPT? I think this question was asked before I went deeper into it, but just to reemphasize, 3 MPPTs, that's how much you have per 30 kilowatt inverter. 4 MPPTs, that's how much you have per 60 kilowatt inverter. And each MPPT, no matter in which inverter it is installed, each of them has 2 positive and 2 negative ports, and that's what I was talking about, that each MPPT can accept 1 or 2 strings, but if there are 2 strings connecting to a single MPPT, they must be identical in all aspects. The third one column is 208-volt AC 4 wires, L1, L2, L3 neutral. No, I believe you are referring to, just a second. I believe you are referring to this, and the answer is no. You have L1, L2, L3 for backup, L1, L2, L3 for smart, like AC coupled PV or generator. You have you have battery plus and battery minus, 2 pairs. That's why you have 4 ports here. And you have grid L1, L2, L3. I hope that answers the question. How do I stop sharing? Is that sharing? Probably not. I'm sorry. Let me do that again. Okay. I believe now I'm sharing. So yeah, this is what I was showing. You have L1, L2, L3 for load, L1, L2, L3 for smart port, may that be generator, AC coupled PV or load. These 2 plus 2, these are 4 ports, 2 positives and 2 negatives, and L1, L2, and L3. That's grid. So yeah, no 4 ports for AC anywhere. And as I said, neutral and ground are here. And we stop sharing. The dongle communication comes with LAN output option. Sometimes Wi-Fi is unstable. I don't think you have the LAN output option on the communication dongle itself, but I believe somewhere in the inverter you have the ability to have local area network. I'm going to talk to our communication experts and ask them how to make the local area network work. But yeah, I do agree. Sometimes Wi-Fi is unstable. On the commercial, though, it is very important that the internet connection is there most of the time. But yeah, I'm going to try to find that the precise answer to the question. Someone asks, yes, but with the higher elevation, you get generally the cooler it will be. Doesn't that offset air density factor when considering the air cooling of the inverter? No, it does not offset it, and it does not offset it for our inverters. It has not provided that offset for generators previously. So this is like general engineering. It's not our product specific. eSpire Mini has an elevation limit of 1,000 feet. What is the difference? Architecture is different. Architecture is different. With that, what I mean is that you have eSpire Mini. On the left side, you have batteries with the HVAC, which shares the wall with the PCS compartment. And the PCS is within its own enclosure itself. Here, you have this inverter hanging on the outside. There's no enclosure around it. There are just fans around it. And also, the fans provide the cooling to the heatsink behind it. Whereas on the eSpire Mini, the way the airflow is designed is that you have huge inlet on the door of the PCS side cabinet, and you have huge exhaust on the side of it. So the entire compartment is cooled, and the PCSs have their own fans. If we were to design something like that for this system, then it would lose its advantage of being so compact. Can you use it with a split phase? No, so far, no. Maybe something's going to change. Theoretically, I guess it is possible, but the inverter must be configurable for it to the state in which it works with a split phase and omits that L3 altogether. Maybe in the future we're going to do something like that, but at that point, might as well use our split phase inverters that we have already available, and that is a mature technology. Is this only Y and not Delta three-phase? Yeah, this is Y configured system. It's not Delta. For Delta, I guess you would need a transformer. You can make it work, but by itself, it doesn't work with Delta. Any other questions? Let's say 2 more minutes for questions. There are no other questions so far. Someone asked, what is the AC for on the battery? The AC on the battery side is for that HVAC that I was mentioning. And also the AC is used to create that 24-volt output for the fire safety systems and for the 24-volt control logic systems. Okay. It seems like there are no other questions. With this, I will then conclude the webinar. I will call this a day. And please keep an eye out for that notification in your inbox with an invitation to attend this new upcoming webinar where we're going to talk more about commissioning. Thank you very much. Thanks again. Good luck to you all, and have a great day.